We're going to have a look at two differentiating techniques. The first one being the product rule, the second one being the quotient rule. Let's have a look at the product rule first. Suppose we have got a function which is a product of two functions. Let's say it's h of x times g of x, and we want to take the derivative of that thing. So we would use our notation and we'd say d dx, which implies the small change with respect to x, being this long expression here. Now, I do respect that this notation can be confusing, so we're going to simplify it a little bit. Let's say we've got a function which is u times v, where u and v were those two functions, the product of them. We would say that the derivative is going to be u dash v plus v dash u, which is the derivative of u times v plus the derivative of v times u. Let's apply it. And so here we've got a question. It says, here's a function, and we can see it is a product of two functions. Determine the derivative and then hence calculate the coordinates of the point with a gradient that is equal to 2 on f of x. In order to find information about the gradient, we need to know what the derivative is, because we have seen the relationship between a function and its derivative function. We looked at it in class. So if we want to take our derivative here, we need to use the product rule, because we've got a product of two functions, where this first guy here, I'm going to say that's u, and this second guy here, I'm going to say that is v. So we've got the product of u and v. So when we go to differentiate a function and we're using one of our techniques, we need to let the marker know which technique we're using. So I would say find f prime of x by the product rule. Okay, PR, product rule. And I would write out the product rule. So I know I've got u dash v plus v dash u. I need to find these four respectively. So I know that u is equal to x squared plus x, and v is equal to 1 on x minus 1. Now I need to find the derivative of both of these functions independently in order to substitute it into my product rule. So u dash, I can apply the power rule just looking at u. I've got 2x plus 1. That's just the derivative of this to be that, u to u dash. That one's easy enough. Second one is not as simple. Okay, however, I can rewrite this as x to the power of negative 1 minus 1. Okay, that's just 1 on x is x to the power of minus 1. And then I can apply my power rule here and say I've got negative 1 and then x to the power of minus 2, where I'm taking 1 from that power, and that minus 1 term vanishes, so I can clean this up a little bit and say I've got negative 1 on x squared. Well, I'm expressing my v prime there with a positive index. Now I've got all of the pieces to put into my product rule. I have got u prime, which is just here. I have got v, which is here. I have got v prime, which is here, and I've got u, which is there. I've got my four expressions to put into my product rule and determine what the derivative of the function is. Just a little bit of a simplifying that goes along the way. Okay, so I've just substituted those terms in there, those expressions in, and now I'm just going to clean this up a little bit by just using my simplifying techniques. So it's expanding the brackets and collecting like terms. Okay, so there I've just expanded brackets. Now I'm going to go through the process of simplifying and collecting like terms. So this first guy here, those x's are going to cancel off. So I'm just left with 2, subtract 2x plus 1 on x minus 1. And then here, well, both of these terms in the brackets are negative. So I'm just going to have minus x squared divided by x squared is just 1. And then I've got minus, and this power is going to cancel off with that guy there. So I'm going to have 1 on x subtracted away. And now I just have to collect like terms and clean it up a little bit here. So I've got a 2, but then minus 1 and minus 1. So I've got minus 2 subtract 2, so they're going to cancel off. And I've got a 1 on x subtract 1 on x, so that's going to cancel off. So I'm actually just left with negative 2x. And this is the derivative of my original function here. You can differentiate this using the product rule. You could have also looked at this function here, and I'm going to do this in a black to the side. I've got f of x being equal to x squared plus x, 1 on x minus 1. And you could have just expanded these brackets and applied the power rule. So my function was actually minus x squared plus 1, just expressed as a product. And we know that in order to differentiate that, we just apply the power rule and we get minus 2x. So you can do that double check there if you like. However, if a question's asking you to use the product rule, you need to use the product rule. And also, you're not necessarily going to be given a product of two polynomial functions or power functions all the time, okay? Sometimes you might get a function that looks like this. Okay, in which case you would have to take both of those functions separately by using the product rule. Okay, you can't just turn cos of x times x squared into a power function. Not going to work. So this is where this technique comes in useful. Now to answer our question, hence calculate the coordinates on the point with a gradient of 2 on f of x. So I need to know where on this function, and if we can visualize this function on a Cartesian plane, what are the coordinates where this function is going to have a gradient of 2 or a rate of change of 2. And so if we can imagine, we've got at each x point, we're going to have a different tangent line. And so the question is more or less saying which x and y point am I going to have a tangent line that has got a gradient of 2. Okay, and so here I'm just saying recall. This is what the derivative is telling you. So when we're having a look at this, we're saying, well, f prime of x is equal to 2. Where? What is the x point where that occurs? So we can work that out. Or we can determine what the x point is going to be by saying 2 is equal to negative 2x. That is, when a derivative function is equal to 2, what is the corresponding x value? And we see that we're going to have a corresponding x value of negative 1. And then to determine the coordinates of that, well, we're saying, okay, where is the corresponding y value on our original function? So when x is equal to negative 1, where is the corresponding y value? And so there we can see that the corresponding y value is going to be 0. Therefore, negative 1, 0 are the coordinates on f of x where the rate of change is 2. Or where the gradient is 2. Remember, rate of change is just gradient. So the rate of change is equal to 2.